So we started this company initially thinking to just trial and error to look into what we could do. We did not have any commercial objective at that time. We started the company without any funding, by just grouping a group of engineers that wanted to do the things to fun things together. We started to look for a few corporates in Japan that believe in us, that allow us to try new things, and that's how we began. We set up a shop in a lab in Vietnam, in Hanoi, started to recruit a few young engineers to work together with us. And without us realizing, the company just grew very quickly. In the first 2 years, early stage, we just started the company. We just had a few engineers working with us. And we grew very fast, but without any real business proposition. We first established a commercial team in London, where I was, and we also started a Singapore office about 1.5 years ago. And that's when we started to scale the business up. We started to have a few very large corporate in the financial sector to basically work with us, to not only work on the proof of concept, but into large scale implementation projects as well. We started to expand internationally, not only in the UK, but also not only in Japan and the UK, but also into Singapore, into the Middle East, and a few other countries that we are still exploring. For example, in Europe, in Germany, in Switzerland, as well as some countries in the Latin America as well. As you might notice, the market trend in the first few years were mostly proof of concept. In the last 2 years, we started to see the market trend shifted from just proof of concept to large scale implementation. A lot of the large companies, they are starting to make it real. They're starting to realize that it's not only the AI engineers that require, but they're also trying to bring in more domain expertise. They're trying to bring in what it takes, the total project management, the total project resources it takes to actually implement in a large scale project. But this technology is now starting to be commoditized over the time, and we're starting to see real technical implementation, not in just trial, but into implementing into large scale projects. The shift of the technology focus was more or less on the accuracy of the AI models in the early years, to now it's more about the sustainability of the accuracy over the time, as well as the improvement over the time. How can we actually work together between the human, between the operator, between the business experts, as well as the technical experts together to sustain the AI accuracy, as well as to scale it up to different use cases. And that is the shift, the big shift of the mindset of the engineers over the last few years. So the business world are starting to get very serious and starting to try to come across all the obstacles, not only from the technical point of view, but also the business point of view of how can we actually address this issue to widely adopt this technology into everything, every code that we do today. And that is a very healthy development of this community to actually grow as one, to make sure that this technology can be sustainably grow and adopt into the society that we have, that we live today.
The 3 use cases, applications that I wanted to share today to just give a flavor of what we built and sort of some of the technology that's been involved. The first one is around mortgage loan sales compliance. So I think all of us have applied for loans before, whether it's student loans, house loans, and so on. So in the process of applying for loans, you will provide all sorts of documentation, and then the officers need to check and make sure that all this data is validated. And then there are some compliance regulation requirements that are being performed on top of this. So that's the first use case. The second one around investment management, ESG risk assessment. This one is very, very new. I think it's a new area that's coming out in this year, where a lot of governments and corporates are moving towards sustainability, or what they call ESG, environment, social, and governance reporting and trying to do things in a more sustainable way. So for investment managers, they need to start taking into account ESG when they consider the risks and also the rewards of investing in a company. The last use case application that I selected is in a construction space actually. It has to deal with large construction companies having to estimate the cost of building, able to calculate all the building material that is required before they embark on a project. And they derive a lot of this data from floor plan drawings that are currently being manually processed. So across all three applications, the main themes are that there are what we call quite a bit of unstructured data that's being involved that currently is being manually processed, and that's where we try to apply the technology to make a difference.
I think so. There are some requirements for the good AI developer. So, yes. So the first one, I think about 4 points for the good ML engineer. So one is the strong curiosity about the technology. This is obviously important. So the curiosity is the most important to keep up with the latest research or technology. And second one is ability to develop according to the client requirements. So creating the good model in business is more than just creating an accurate model. So I think that this is the biggest difference between the academic AI, between the academic AI and the business AI. And we need to consider the non-accuracy requirements, such as the environment, so in which the model will run. For example, we can use GPUs, or we cannot use the GPUs, or model will run on the iOS, for example. So this, yeah, we need consider of the non-accuracy requirements. Yes. So and third one is the problem solving skills. So on the way of development, so we will encounter problems, so large and small, and we need to be able to solve this problem as smoothly and alone as possible. So the developer who can solve everything by themselves are very easy to manage. So we will want to ask them to do the next job. Yeah, this is the third one. And the final one is the communication skill. Of course, this is important. So as we will not work on the project alone, so the ability to communicate our situation and the development progress to the project other members is really important. Yes. Okay, thank you. Good. So yeah, I will introduce a day in my life. So first of all, so I wake up from a long sleep. So if I sleep less than 9 hours, I feel so bad. So as soon as I wake up, so I eat breakfast, and after breakfast, so I will go to gym for the weight training. So yeah, so morning exercise is good for my body and mind. And after going home from gym, so I start to work. And my first task is to continue the previous day's conversation or discussion and reply to the messages I received while sleeping. So Nexus has a lot of different time zones members. So I often receive the messages during my sleeping. So after communication on Slack, so I have a lunch, and after lunch, so I change where I work. So I go to the co-working space for a change. So and once I'm at the co-working space, so I start coding. So the coding is the most important time for me. So and at this time I completely ignore the Slack communication and focus on the coding. And once the coding is finished, so I will return to the communication on Slack. And mainly here, I give some technical advice to developers, and I do the code reviews. And then in the evening in Japan, the meeting time will come in the evening in Japan. So UK member in Nexus start working in the evening in Japan. So the meetings with UK member can only take place in this time. So after the meeting with UK member, so I go home and have a dinner, and I do this 1 hour, so 1 hour cardio, and during the cardio, I organize the works I need to do tomorrow in my brain. And after cardio, I do coding and research the paper until bedtime. This is the weekday lifestyle.